All right, so with question number 9, we are picking up and diving into the word problem section of the practice test. Now, these can be difficult, and so the method that I show you here in the videos may not necessarily be the method that your professor shows you in class. And if they don't have a preference about which method you use on your test, then choose the method that works best for you. If you like the way that you learn from your professor in class, by all means, please continue to use that method. If you like the method we're going to show you here and you find it easier, then please use this method. But just be sure that your professor doesn't want you to use a specific method, right? Because whatever they want you to use is what you're going to need to use on your test. But this is called the box method, and you can see that we have created a tic-tac-toe box here on the screen, and we're going to take the information that's been given to us in this word problem and plug it into this box. And this box is going to help us to derive the two equations that will create the system of equations that we're trying to solve. Because remember, for each of these word problems, we're really coming up with a system of equations, just like we've been doing up to this point on the practice test. And then once we have those two equations, then we're going to solve either by elimination or substitution, depending on what you're more comfortable with. All right, so these can be difficult, so make sure that you're getting plenty of practice. You're doing not just the few examples here in this the practice test, but please make sure you're doing your homework, because you're going to see a whole bunch of them in your homework, and you're going to get comfortable with them the more you do. If you only do the few here in the practice test, that may not be enough for you, and so make sure you're doing your homework. Also, because these are difficult, I went ahead and put together a reference sheet a couple years ago for students, and this reference sheet covers every type of word problem that you're going to see in this chapter. And so, if you come to the PASS lab, this will be my free gift to you, this reference sheet. I'll make sure there are plenty of copies there in the PASS lab, LL237. On the Gardens campus, and you'll be able to utilize this reference sheet while you're doing your homework. You can't use it on the test, but it will help you while you're doing the homework, while you're doing the practice test. And I have it broken down into several sections. So there's something called board problems. So I have the basic model of how you set that up, and then an example of how you would utilize the model. We have investment and ticket problems. This is the model, this is how you set it up, and then an example with a word problem. And you can see I try to use colors to help you navigate and show you where to plug in information into this box. We have a mixture problem, which is exactly what we're about to do here in number 9. And then we have some distance and rate problems that we'll be getting into later on. So I'll make sure there are plenty of copies in the PASS lab. Again, LL237 on the Gardens campus. Stop by and make sure to pick up your copy. And I think it'll help you to tackle some of these word problems. But let's get into this word problem, number 9. And it says, Ellen wishes to mix candy worth $2.16 per pound with candy worth $3.72 per pound to form 26 pounds of a mixture worth $2.76 per pound. How many pounds of the more expensive candy should she use? Well, that sounds like a whole bunch of information that they've thrown at us. And first things first, when you're using this box method, go ahead and always label this top left box X and the box right below it Y. All right, so this is what we are always going to label these two boxes, X and Y. Because again, remember, we're creating a system of equations here. We're creating equations. All right, and now X and our Y, and then go back to the word problem and look to see how much of the new mixture are we looking to make. And if we look through here, we can see that Ellen is trying to form 26 pounds of this new mixture. And so the total of what you're trying to make, the newly created mixture, goes here. So 26. All right, well now let's go back to the word problem, and we have to figure out what price is associated with X and what price is associated with Y. Well, let's see, because X is going to be one type of candy, the candy that costs one price, and the Y will be the candy that costs the other price. So if we go back in here, we can see that we have candy worth $2.16 a pound, and we have candy worth $3.72 a pound. All right, and then we have that she wants to sell this new mixture for $2.76 per pound. And so we're going to put the cost of the new mixture in this bottom box here. All right, so let me go over again what each of these boxes is going to contain. This top left box, always your X. This the box right below it, always your Y. And then the bottom left box here is always going to be the total weight of what you're creating, the new mixture of what you're creating. So go back to your word problem and see, well, how much weight is the new mixture going to be? And we can see that it was 26 pounds. All right, the X and the Y always represent the two pieces of the mixture. And generally, I make my X the lesser expensive mixture, and the Y the more expensive part of the mixture. And if you go back to the word problem again, you can see that she's mixing two different candies, each of them having a different cost. One costs $2.16 per pound, and so again, I assign the lesser expensive candy to the X, and $3.72 per pound is the cost of the more expensive candy, and so we put that in the box corresponding to Y. And then we find that the new mixture is going to be $2.76 per pound. That's what Ellen wants to sell it for, and that's the cost that we put here in the center bottom of our grid. All right, so the next step is once we have these two columns filled out, we're going to multiply from left to right. And so X times 216, well, that's just 216X. Y times 372, well, that's just 3.72Y. And 26 times $2.76 is going to give us 71.76. And now once you have your grid filled out, once you have your tic-tac-toe filled out, the columns on the left and right become your systems of equations. So pulling the information right out here, we have X plus Y equals 26, and then 216X plus 372Y equals 71.76. And you can see that we now have two equations that we can either solve by elimination or substitution. And I think for this one, I'll go ahead and solve by substitution. And I'm going to start with this first equation, and let's solve this first equation for Y. And to do that, we're going to subtract X from both sides, and so that will give us Y equals 26 minus X. Excuse me. And now that we've solved for X here, we're going to take this value, or excuse me, we've solved for Y here. We're going to take this value of Y and plug it into our second equation where we see that Y. And so let's go ahead and rewrite equation number 2, only instead of using Y, let's use the value of Y that we just solved for. So we have 216X plus 3.72, and what is the value of Y? Well, 26 minus X, we just solved for, equals 71.76. And now let's go ahead and clean up the left side, and we'll distribute that 3.72 through as we do. So 2.16x plus, well, 3.72 times 26 is going to give us 96.72 minus 3.72 times negative x gives us that minus 3.72x equals, and then 71.76 has not changed. All right, so now I see that we can combine some like terms. So we have a like term there and there. So let's go ahead and combine that. At the same time, we can subtract this 96.72 from both sides. Oops, that's 96.72. All right, so let's see. So 2.16x minus 3.72x is going to give us a negative 1.56x. And then 71.76 minus 96.72 is going to give us a negative 24.96. And if we want to solve for this x, let's go ahead and divide by -156. You might be able to hear that loud thunder outside. It's getting ready to storm. All right, and so when we do this division here, we get x equals 16. All right, so now that we've solved for x, let's take this value and plug it right back into the first equation that we manipulated, because as soon as we take this value of x, plug it in, and solve, we have our y. So we have y equals 26 minus, well, instead of x, we're going to plug in that value that we just discovered. And so we have y equals, well, 26 minus 16 gives us 10. And so now we have a value for y, we have a value for x. But be careful here, because you might be tempted, like we've done in the past, to just go ahead and put this right into an ordered pair as the solution and move on. But with a lot of these word problems, they're not necessarily asking you for the ordered pair, the solution. They're asking for a specific part of information. And so let's go back and look at that last question again. And it says, how many pounds of the more expensive candy should she use? Well, let's see. I have a y equals 10. And again, remember, these units are in pounds, right? And we have an x value of 16. Well, if you don't remember which candy the x and y represented, if you don't remember if the x was more expensive or less expensive, or the y was more expensive or less expensive, go back to this table and you can see that the x was associated with the candy that cost $2.16 per pound, whereas the y was associated with the candy that cost $3.72 per pound. And so the y was the more expensive candy. All right, and so when it asks us how many pounds of the more expensive candy should she use, we're going to look at the y and see what that value is. So we're using 10 pounds of the more expensive candy, and so in this case, our answer would be 10 pounds. All right. Now, I know that these can look really confusing because there's a lot going on. We're using a table here, you know, our tic-tac-toe grid, and we're taking information from our grid and then using that information to set up a system. But the more of these you do, you will get really comfortable with them. And again, I think if you can stop by that past room, pick one of these up and these reference sheets up, and it will help you to navigate some of the more difficult problems. But the more of these you do, you'll get comfortable with them, I promise. So that's why I really am trying to emphasize not only do these examples from the practice test, but make sure you're doing all of your homework, because there are absolutely going to be a number of these on your actual test, and you don't want them to trip you up. All right, so that was number 9. Let's go ahead and take a look at number 10 in our next video. This was Joe Brownlee with Palm Beach State. See you there.